Hi, my name is Mr. Chon and I welcome you to my study room. If today is your first time, then I want to encourage you to subscribe to this channel for more videos. In our last study, we did the equation of a circle in the standard form, or the standard form of the equation of a circle. And I promise in the next video, you are going to do the general equation of a circle. So here we have today's study, the general equation of a circle. And I encourage you to pay attention as we go through. So I want to encourage those who have not watched that video yet to watch before coming to watch this one so that the understanding will be clearer. We start right from there. So in that video, we said that the standard form of the equation of a circle with center having the coordinate a, b, and a radius given is x minus a all squared plus y minus b all squared being equal to r squared, which is the radius. Alright, today we are continuing by expanding the left hand side of this equation. So when we expand the left hand side of this equation using binomial expansion, we are going to have x squared minus 2ax plus a squared plus y squared minus 2by plus b squared be equal to r squared. Good. Then we want to group all the constants at one side, meaning the terms without x at one side. So we are going to have a squared plus y squared minus 2ax minus 2by plus a squared plus b squared minus r squared equals 0. Now at this stage, we are going to replace negative a by g. Let negative a be equal to g and negative b be equal to f. Our equation now becomes x squared plus y squared plus 2gx plus 2fy plus g squared plus f squared minus r squared equals 0. But then here you can see that this g squared plus x squared minus r squared all don't have any x attached to them. So it means that each of them is a constant and we can use one constant to replace all of them. So we'll use c in this case, and our equation now becomes x squared plus y squared plus 2gx plus 2fy plus c, replacing all the constant terms, equals 0. And this becomes the equation of a circle with center negative g, negative f. And we are calling it negative g, negative f because from here, if you want to make a the subject, remember the center as at this stage was a and b. So here you see that if you want to make a the subject, the g will be negative, and if you want to make b the subject, the f will be negative. So This is a general equation of a circle with center -g and -f, and the constant term c equals g squared plus f squared minus r squared. And from here we can get our radius as well from here, because we are just making the r the subject of this equation. So our radius becomes, first of all, r squared will be g squared plus f squared minus c, and our r, meaning we should take the square root of both sides to get r equals square root of g squared plus f squared minus c. All right, we take some example. But before the example, the equation of a circle, as you've seen it this way, has some important properties that we need to identify so that we can use it to identify whether the equation we are seeing is an equation of a circle or not. And these properties are: number one, the equation of the highest degree of the equation of a circle is 2. That means the highest exponent of x and y is 2. So the highest exponent of x and y is 2. Is the equation of the degree 2, or the second degree as the highest. And then number 2 point or property we need to note is that it doesn't have x, y terms. So you can see that from x squared, y squared, we go to x term, y term, and then constant term. So you don't have any term involving xy. So there is no xy term. Then the third and final property that is worth noting for us is, in the equation of a circle, the coefficient of x squared and y squared is always the same. Yeah, the coefficient of x squared and y squared are equal. It's not always that the coefficient of x squared and y squared are 1, but they should be equal. Whatever the case is, they should always be equal. So if here is 3, here should be 3. If here is 4, here is 4. So with this, at times you can meet some of these things in your exams, and you need to remember these properties. So a question can actually be set to test your understanding of this. For example, this is question 27 of WASI 2020 Add Maths or Elective Maths paper. And the question is simple: which of the following is not an equation of a circle? And if you don't know these properties, it will be very difficult for you to find. So let's take them one by one. When you see this one, it follows the first property I stated there. You can see that it is an equation of 2 being the highest degree. So this is x squared, y squared, x squared, y squared, x squared, y squared, x squared, y squared. So it follows that one. Then the second one is that we don't have xy term. So when you check here, we don't have any xy, we don't have any xy, we don't have any xy. But then when we get to the third one, the very first example here, this one, already the coefficient of x squared and y squared are not the same already, because this is the coefficient of this is 1 and this is -1. They are not the same. That is not what the property says. And when you check all the others, you can see that they are the same. Here we have 5, here we have 5, here we have 1, here we have 1, here we have 3, here we have 3. But it's only in the first one that the coefficient of x squared is 1, but the coefficient of y squared is -1. Therefore, A is our answer. In this case, A is our answer. I just went to pick this past question, WASI 2020 further maths or elective maths objective question 27, just to demonstrate to you that the properties are very important and therefore we need to take them seriously. We go back to the general equation. So now, after getting this general equation, having the parts being explained and then taking the properties, we can now take an example. And I'm not going to do anything too different. I'm just going to take the very questions we answered using the standard form of the equation to see whether the general equation will give us the same answers. So let me just write the question quickly. So the instruction is the same. Use the given center and radius to find the equation of each of the following circles. And the first circle has center coordinates 2, 2 and radius 5 units. We are going to use the general formula in solving this. And we have to quote the general formula first, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0, where the center is negative g, negative f. Since the center coordinates here are 2, 2, and it's supposed to be, the center is negative g, negative f, it means g will be negative 2 and f will be negative 2 as well. So let's substitute that. We are going to have x squared plus y squared plus 2 negative 2x plus 2 negative 2y plus c equals 0. This will give us x squared plus y squared minus 4x minus 4y plus c equals 0. And I don't want anybody to be confused by this. We are just, when you remember what we did in the previous video, we said that we let g equals negative a and f equals negative b. That's what we did. So if this time we want to make a the subject, then we will divide both sides by negative 1. So we are going to have negative g. That's what we are doing here. But g, this is our a, this is our b. Okay, so now we are replacing the g. So we have to, if a is 2, then negative a will be negative 2. And if b is 2, then negative b will be negative 2. That's how we got this. So I don't want anyone to get confused by that. Then now we have the c. We don't want the c. But remember, earlier in this formula, we said that our c equals g squared plus f squared minus r squared. So that is just what we are going to do to get our c. So we know our g to be negative 2 squared plus our f, also negative 2, we have to square it, minus our r is 5. So we have to square the 5 too, because it's r squared. So this is going to give us 4 plus 4 minus 25. And this will give us 8 minus 25, which will give us negative 17. Alright, so that means the equation of our circle, we are substituting our c back into the equation to get x squared plus y squared minus 4x minus 4y minus 17. Remember this one, I said negative 17. Let me just clean it and write it well. 8 minus 25 is negative 17. So minus 17 equals 0. So I'm sure this answer we got here as the equation of this circle, x squared plus y squared minus 4x minus 4y minus 17 equal to 0 is the same answer we got when we had this one, the standard form where we expanded to get our answer is the same thing. So that shows that any of the two can be used to find our equation. So we just have to show the one that we should master. So then again, I'll do the question 3 from that video using the standard form. I'll use the general formula to solve the question 3, which I ask you to do it on your own and compare the answers. I'm going to do that one using the general formula, then I'll give you another one to try on your own using the general formula. So let's take that one quickly. In our example 2, like I said, it is the third example in the previous video when I use a standard form for you to find the equation. So you're using the general equation to find that as well. So the circle has the center coordinate -3, -1, and then the radius is 4 units. So as usual, we have to quote the general equation first: x squared plus y squared plus 2gx plus 2fy plus c equals 0, where the g is -a and the f is -b. So by substituting that in, our equation now is going to be x squared plus y squared plus 2, our g is 3 because negative of -3 will be 3x plus 2 times 1y plus c equals 0. Then we simplify further to have x squared plus y squared plus 6x plus 2y plus c equals 0. Then we have to find the value of c. We don't want any constant, we want all numbers. So the value of c, we know c is g squared plus f squared minus r squared. So substituting the value, we are going to have 3 squared plus 1 squared minus 4 squared, and this one, to simplifying further, we are going to have 9 plus 1 minus 16, and this will be 10 minus 16, which will give us -6. So our equation now becomes x squared plus y squared plus 6x plus 2y minus 6 equals 0, which now will be the same as the answer we got from that one I asked you to solve on your own. We had x squared plus y squared plus 6x plus 2y minus 6 equal to 0. So that shows that it's the same for both of them. So I'll give you one which you will try on your own. You pause the video and try your own, then you find the answer. So the third one is you should use the general formula to find the equation of a circle with center coordinate -6, 2 and radius 10 units. So if you do it well, you should have x squared plus y squared plus 12x minus 4y minus 60 equal to 0 as your equation if you solve it well. If not, go back and check your work well and make sure you find where you made a mistake and correct it. I hope this video has been of help to you. If yes, then again I encourage you to go back and subscribe to this channel for more videos. so that you'll be alerted anytime I post a new video. Feel free to share any comment with me in the comment section and I'll gladly respond to it. Thank you for making time with me, and I hope to see you another day in my study room. Bye bye.